In this lesson, we're going to look at how you can manage logging on your network devices. When a specified event occurs on these devices, a log message is generated. These messages can be an invaluable resource when you need to troubleshoot network problems. To be able to use these log messages, you first need to understand how logging works. Most network devices and servers, with the exception of Windows servers, use a version of the syslog process to create and manage log messages. Windows servers use their own logging system by default. However, you can install an open source syslog service on Windows servers to allow them to create log messages that are compatible with syslog. The syslog process controls the distribution of logging messages to various destinations depending on the configuration. For example, messages could be sent to memory, to a file, or to a syslog server. On some devices, such as switches and routers, it can also display log messages on the screen. Let's take a look at a sample syslog message. Now, this particular log message was created by a Cisco router. The message itself contains several elements, all of which provide useful information. The first element is the timestamp, which indicates when the message was generated. We can see this message was generated on August the 8th at 11:18. The next element is the facility. The facility identifies the subsystem that created the message. In this message, it's %lineproto, which is a Cisco-specific facility. On a Linux server, you might see other facilities listed. For example, the current facility specifies the message was generated by the Linux kernel. After that, we have the severity level. This indicates the severity level of the message. The severity level of this message is 5, which indicates an issue of concern that doesn't represent a problem. The message severity level ranges from 7, which indicates debug information, to 0, which indicates an emergency that will severely affect the system. Next is the mnemonic. This element helps the administrator quickly identify the nature of the message. Last is the message text element. The message text provides a description of the event. In this example, the line protocol on the interface FA00 was changed to a down state. By default, most network devices, including switches, routers, firewalls, and servers, store log messages locally on the device. However, these devices can usually be configured to redirect log messages to a centralized location on your network. Moving your log files from the local device to a different computer on the network can be a very valuable administrative and security measure. For example, you could redirect logging from all infrastructure devices on your network to a single log server. Then, if an issue arises that you need to troubleshoot, you have instant access to all of the log files from all of your network infrastructure devices in one location. This eliminates the need to visit each device individually in order to access its log messages. In addition, remote logging increases the security of your servers and devices. Inexperienced intruders tend to leave footprints all over in the log files of the systems they break into. However, experienced intruders will try to erase their tracks by altering the log files after compromising the target system or device, making it very difficult to detect the intrusion. But if you redirect your logging, the intruder will have a much harder time covering their tracks. Now, to consolidate log messages on a central logging server, you need to reconfigure these devices so that they send out their log messages to the remote host you are using for log message aggregation. The way you do this depends on the type of device and its manufacturer. You'll need to consult your device documentation for specific configuration steps. For example, to configure remote logging on a Cisco device, you would use the following commands. First, you use the logging on command to enable logging. You then specify the IP address or host name of the syslog server that will receive the messages. After that, you specify the type of messages that will be sent to the server based on its severity. Messages with a severity level less than or equal to the specified number will be sent to the syslog server. On a Linux server, the remote logging process is configured differently and involves adding a line to the syslog.conf file and restarting the syslogd daemon. Now, a common implementation for remote logging is having a Linux server as the destination log host. If this is the case, then you need to configure the server to receive log messages from the other systems. This is done by editing the syslog file in the etc sysconfig directory and setting the syslog-d params directive to a value of -r. That's it for this lesson. In this lesson, we discussed managing logging on network devices. We first discussed the syslog logging process that is widely used by many different types of network devices. Then we looked at how to interpret syslog log messages. And we ended by discussing how to configure remote logging on both the device and the logging server.